We've been using this analogy between algebraic expressions involving variables like x squared plus y plus 21 and well-formed formulas like P and not Q implies R. And just as x squared plus y plus 21 doesn't have a numerical value until you substitute in some numbers for x and y and then combine them using plus and multiply, a well-formed formula doesn't have a truth value until you decide on truth values for the propositional variables and then combine them using the connectives in the well-formed formula. But while we all know how to do addition and multiplication to combine numbers into a single number, we don't yet know how we're going to combine these logical values using our connective symbols. And that's the subject of this video, in which we're going to learn how, given a truth assignment for a set of propositional variables, we can come up with a truth value, not just for those variables, but for any well-formed formula that uses those variables. So let's look at what's going to seem quite a complicated definition for doing that. So given a truth assignment on a set of propositional variables, we extend it to give truth values to any well-formed formula by making a definition. And the definition looks quite complicated, but what's going on there is we're saying that any well-formed formula which isn't a propositional variable is either two well-formed formulas combined with the and symbol, or combined with the or symbol, or combined with the implies symbol, or a single well-formed formula with the not symbol in front of it. So we can just make a definition for each of those cases. And what we do is say that the truth value, v of phi and psi, is the same as the truth value of phi combined with the truth value of psi using the and truth table. And similarly for all the other connectives as well. So this does seem a little bit complicated, but if you think about what's going on there and you think about using this rule repeatedly, then what you realize is this is just substituting in for the truth values given by the truth assignment to the propositional variables and then combining those truth values using the rules given by the truth tables. So let's look at an example at the bottom here where we have a truth assignment. So we've got two propositional variables P and Q and a truth assignment that makes P true and Q false. And we're going to look then at what truth value certain well-formed formulas get under that truth assignment. So let's look at the first one. We want the truth value of P implies Q under this truth assignment. So what we do is just substitute for P and Q. So I get true implies false. Okay, now if you go and look at the appropriate row of the truth table for implies, so that's the row where the first thing is true and the second thing is false, which is this row right here, well, that row tells you, looking at the last column, that this is false. So under the truth assignment, which makes P true and Q false, the well-formed formula brackets P implies Q gets the truth value false. Okay, next example. Let's look at Q implies P. So in order to figure out the truth value for the well-formed formula Q implies P, we substitute for Q and P. We get false implies true. Now we look at the row of the truth table where the first thing in the implication is false and the second thing in the implication is true. That is this row here. That's the row where the first thing in the implication is false and the second is true. So if we now look at the last column, that's telling us that this is true. Okay, let's move on to our last example. So in the last example, we've got a complicated well-formed formula. The well-formed formula is brackets P implies Q, close brackets, and brackets Q implies P, close brackets. So, well, we need to substitute for P and Q. So we can just substitute here if we want. We can put the T true in place of P and false in place of Q and work all this stuff out. But we've actually done most of the work here already because we know what truth value P implies Q will turn out to be. That will be false. So we can put in here, I'm going to put this in blue here to remind you that this was the first calculation we did. And then we've got and in the middle. And then we worked out the truth value of Q implies P, and that was true. So we've got false and true. So if you want to work that out, you go and look at the AND truth table. You look at the row where the first thing was false and the second thing is true. So that is this row. And you see that the thing in the last column is false. So this is false. Okay, well, using this method, we can give a truth value to absolutely any well-formed formula using a set of propositional variables V once we're given a truth assignment to the propositional variables. Let's try some more examples. So we're going to take P and Q to be propositional variables. We're going to have a truth assignment that makes P true and Q false. So this truth assignment here, which is the same one we had before, and we're going to do a couple of examples. So we'll begin with the well-formed formula phi, which is P and Q, or not P and not Q. And we want to work out the truth value for phi under our truth assignment that made P true and Q false. So how do we do this? Well, we know we can do this by just substituting in. So V, I think I've changed my mind about that colour. V of phi, well, we could do this by substituting in, but we're going to get a pretty complicated, nasty expression. So what I'd actually like to do is just do parts of this formula at a time. I want to think about P and Q, so this bit of the formula, and then I want to think about the other bit of the formula here, which was joined with an OR. So if we look under this truth assignment at what is the truth value of P and Q, that's an easy one because putting the brackets in, that's true and false, which, if you remember the truth table, for AND is false. And if you look at not P and not Q, well, the truth value of not P would be not true, which is false, and similarly the truth value of Q will be not false, which is true. Okay, so if we had the truth value of not P and not Q, well, I know that not P became false under this truth assignment. I know that not Q became true. Oops, I missed the not symbol there, didn't I? Not Q became true under this truth assignment, so we have here false and true, which is false. Okay, so going back to our whole well-formed formula phi, we've worked out the truth value of P and Q, which turned out to be false. Then we have OR. I'm trying to make my OR symbol look different to my lowercase v, which was the truth assignment. So we had false or the truth value for not P and not Q, which was false. Okay, so that thing is false or false, which is false. So under this truth assignment, phi gets the truth value false. Okay, final example then. Let's move down to psi here, which is the well-formed formula on a single propositional variable p, which is P implies P implies P. You might try using your logical intuition. Like, what do you think the answer should be? If you've got a good sense of implies, you might be able to guess what this is going to be. But I'm going to work it out. I'm going to work it out carefully. So how am I going to do that? Well, we can do this by substitution if we want. So let's just do this by doing the complete substitution. So the truth value of psi under this truth assignment is true implies true implies true. Now, looking at the truth table for implies, which was on the last slide, true implies true was true. So this is true implies true, and like I just said, true implies true is true. So the truth value of psi under this truth assignment is true. So let's actually just think for a moment about a different truth assignment. So if I have a different truth assignment, let's call it W. So if we made a truth assignment just for the truth variable P, which made this thing false, then you should check that W of this well-formed formula, W of psi, is also true. And that's interesting because it means psi was a well-formed formula which had only one propositional variable, p. And for one propositional variable, there's just two possible truth assignments. You can make that variable true or you can make it false. And whichever of those truth assignments we chose, we got the same answer for our truth value of psi. It was true under this truth assignment, and it was true under this truth assignment. So that is a special property. Well-formed formulas with this property are called tautologies.